Hello! That almost didn't work. Hey Bastards, how you doing? Cool. Ah, there's so many things yet to do on the old streaming platform. I need to figure out quite a few bits and pieces. Let's just update some of the overlay. Not done that for a while. I've actually made myself a nifty little application for stuff like that. Let's go with stream number 2. And then I just have to go into here and refresh that. The refreshing part's really annoying. That's not working as expected. Strange. Alright, I'm not going to worry about that today. I'll fix it some other time. Anyhow, cool. So today we are going to just do a quick stream. I'm just trying to get back into it and get the reps in. So I'm not going to spend a long time on this because my wife wants to watch TV. So let's just dive straight in. So there's a package that I've been working on called my light controller. And the idea is that I've got these, reaches across the room. The green screen's going to not get rid of this. But I've got these LED strips, which I'm making myself, and I'm writing the controller for those as well. And the plan is to build little mini games that can be played on the actual controller. So for example, this is like the Tug of War thing. Yeah, people joining, picking a side, and then pulling, attacking each other to try and win. And so this is going to be played on the actual LED strips with colors and things. But more so than that, what we are doing is we are building this tool. Where's my code? Because it's fun and I wanted to try it, we're doing this using test-driven development, which means I'm actually writing tests first and code later. And so this is my test class. Let's actually make this a bit bigger. Cool, there we go. So for my Tug of War game specifically, I've got a bunch of different tests. And so I've got a pick sides test, I've got starting positions for 2 players, starting positions for 4 players, movement tests, win tests. And basically what these tests do is they will start a game, they will add players to the game, and then we'll make assertions. Things like, is the game over? No, it's not over. We'll move the players. Is the game over? Yes, it's over now. And so, yeah, I know, I really like the fact that I can increase the size on the IDE. It's so much nicer for people to be able to actually read code. And actually I quite like it, it's like a no distraction mode. It's actually it's quite nice to be able to not have loads of other stuff in the way. I can still get things like my terminal up if I want to, but it's just hidden away by default. So on the one hand, I'm writing my tests, and I'll show you how these run in a second in Unity. And on the other hand, we've got the actual game code. This is a game controller, this is a Unity class, but also the Tug of War game class is completely Unity agnostic. So I'm writing all of my classes in the games section to be completely engine generic, so we can actually run this game in Unity or Godot or anything else that takes C# compiled scripts. So from that point of view, it's really good. Yeah, I watch 90% of my streams on my phone. Like, so when Zach is, for example, when Zach is coding, like, I tend to just turn the video feed off and just listen in. I don't actually look at the code he's writing most of the time because it's too small. But yeah, let's get Unity opened up and see what we got up to last time. So I'm mainly focusing on writing the tests and writing the game code in my library, but I've also got a kind of proof of concept scene in Unity where I can kind of just run the Unity version of it as well, so I can see visuals, because visualizing helps me. Just seeing the tests with green ticks or red crosses doesn't really help me see like what is right and what's wrong. But generally for this approach, we shouldn't actually need to have anything in Unity at all to know whether the game is working or done or whatever, because we're covering everything with tests. So I've got my playing field, and if I just check, there should be 25 LEDs in the strip, and for a 25 LED strip, we can add a few players. That's nice. When the sides are equal, moving does nothing because there's no winning team at that point. But if I add more players to the left, then we start to pull to the left. And if we pull again, we'll win. But actually what I want to do next is, I want to do like, if in the nick of time, more players join the team. So right now there's 2 people on the right team and they're going to lose. But if I wanted to add another player to the right, I'd want that player to join the existing team. But what it does is it resets the playing field. So right now, whenever you add players, it resets the positions, which is okay. Like, we might want to have just like add it, you know, might want to make it fair, and people can't join in the middle of a team, in the middle of a round. So, you know, adding a new player means that the game restarts. But I want to have like the games be interactive, and I want people to still be able to join in as the rounds unfold. So that's what we'll do today. I mean, tests have a lot of benefits, Bastis. The question is, the whole point of tests is that you don't have to try things out visually or manually. So the most common use case for tests is edge case testing and regression testing. And it's basically the idea of, I've built this feature in my game, and I want to have a test that tests whether that feature works, so that if I make changes to my game and break something, I want the tests to catch that, not necessarily a play session, which is what you're saying basically. But often you don't have complete coverage for your tests. Like, you'll have a couple of tests, you won't have tons. Whereas what I'm doing is basically, I'm not writing any code that isn't being tested. So it's a methodology called test-driven development. And I might be able to show it off a little bit in a second. But I've kind of also deviated from it a little bit, and it's just a little bit of fun. So I'm not really sticking to it in a very rigid way, but I'm doing this in a way like, I will write a test to say, when I add a player, I want this to happen, knowing it doesn't work, so that that test fails. And then once the test is failing, I will then change the code to make that test pass, and only when that test passes will I go back and write the next test. And that's kind of the iteration process that we're doing. So far, we have tests for movement, and what our movement is doing is basically, first of all, we're checking that we can move. So there's exceptions thrown if you don't have enough players in the game to actually have 2 full teams. So I think at least 2 players. At least 1 player on each team. If you don't have at least 1 player on each team, the game can't begin. That's what I'm testing in the start. So just making sure that the relevant errors are thrown if there aren't enough players. And then what we're doing is, which one is this? Test movement. this needs rewriting. This is not cleanly written. But basically what we're testing is we're adding 2 players to the left and 1 to the right, and then checking that the relevant lights are on. Then we're moving, and again checking that the lights have updated correctly. So I'm probably not going to change anything about this test in particular, because this is covering a bunch of bases. So instead what I'm going to do is I'm going to write a new test to cover in-game joining. So of course naming stuff is absolutely horrible at. So we're going to write a new test. We're going to say it's a public void test Tug of War in-game joining, because I can't think of a better name. And so let's just write a few comments so we can start this off. So we're going to basically start a game. I'm not going to do that yet. We are going to add players. We're going to move. We're going to add more players. And those are our basic steps. And then we're just going to make sure that the right people are in the right place. And let's just write that in quite a quick and rough way. So starting the game, we just create a new Tug of War game. Adding players, what we're going to do is game dot add player to left team, game dot add player to the right team, and we're going to add 2 players to the left team. Then we're going to move. Then we're going to add 2 players to the right team. And we're going to move again. And what we're expecting is, before we move, we're going to expect these players to be in their starting positions. After we move, we expect everyone to have moved 1 step to the left, because that's where the next spacing is. And then we will add more players. We will check again exactly where everybody's laid out, because we're expecting more lights to have turned on. And then we will move again and again check that everyone's in the right position. And that should be enough to cover off the bases for this. So you can see here I've written a bunch of different test cases. What test cases are really good for is basically saying I have a bunch of different versions of this that I want to test. So what I'm basically doing with my test cases is I'm testing what will happen if I have different numbers of lights on my LED strip. Because if I just quickly jump into the game, for example, if we have only 5 is the minimum number of LEDs we can have in a strip, there's not enough space for a ton of players here. If I add a player to the left and add a player to the right, that's like the maximum. If I add another player to the left, I can't, because if I had 2 players on the left, then once I've moved, 1 player would fall off the playing field. We need to have enough lights turned off as a buffer so that people can actually do enough moves. So 5 actually isn't a playable size at all, because it can have starting positions, but no one can win because we can't have enough players to actually move. In this version of the game, in the final version of the game, 1v1 or 2v2 will still be able to compete against each other, but just for simplicity, I'm keeping that to later. So if I bump it up to like 8, and then put 2 players left and 1 player right, now we can move, and the team wins. And you can see the starting positions are different for different board sizes. So the ideal starting position is 3 moves from winning, but let's say if we go to 10, for example, for a 10 LED strip, the starting position is 2 moves away from winning. However, if I add more players, we've now moved everybody in, so they're only 1 position away from winning. In order to make sure we still have enough space, I've had to move everyone into the board more. And that's what I worked on in my last stream, to have the dynamic starting positions based on board size. And so we're going to start with some very simple assertions. I think let's start with one test case. And let's say we want to start with, let's have 10 LEDs. Our starting, what could we test? There's too much testing going on here already. We basically need to, there's too many lights, there's too many variables. So we can't do a simple test case with just a couple of numbers being passed in. We have to use a slightly more complicated test scenario. So I'm going to use something called a test case source, which is basically where I pass in a bunch of different properties for the checks. So right, let's write something. So test case, what's my test called? My test is called in-game joining. We're going to call the source in-game joining cases. That's going to be you. And what is a case going to be for this? We're going to have a total number of lights. We're going to have some light checks, and we're not going to need players will fit. Let's make this a bit more readable, actually. So rather than having light checks, we're going to have starting positions. We're going to have starting positions after move, starting positions after join, and starting after join and move. Why not? All sounds good to me. So we've got an int and 4 light checks. Let's do the same thing here. Boom. I really love AI coding. It makes life so much easier. Okay, so here's my test cases. Just pop that in up here. Now, light checks. This is the parameters that we need. This is a mess to read at the moment, so let's make that a bit cleaner. I need 4 light checks, so 1, 2, 2, 3, 4. And get rid of the rest of these because I'm just going to do one to start with. Okay, so our getter has one case. Okay, so now we've got to decide which kind of light checks we're going to be checking for. Let's just do it in the simulation. So let's say we're playing 2 players left and 1 right. So we are going to be checking that 0, 1, 2, 3, 6. 2, 3, and 6 are turned on. We're going to check that 2, 3, and 6 are on. Those are our starting positions. And actually, this one's not going to work. We can't do a 3 yet, a 10 LED one yet, because 10 LEDs means we're too close to the center and we can't actually test movement. So let's park 10 for now. We'll get back to 10 later. Let's do 15 instead, because 15 should be big enough. Let's just do a quick check to make sure that's the case. 1, 2, 3, move. 1, 2, 3, move. Okay, I think that'll be fine. So with 15 LEDs, we are looking at 0, 1, 2, 3, 4, 10. 3, 4, 10. Then after a move, 3 and 4 are in the win, so they'll be pulling, so it should be 2, 3, 9. I'm not going to use the prototype from now on. I'm going to try and work these out myself, just so that the test is more accurate. Well, the idea is you should decide what the winning condition, not the winning conditions, that's the wrong term, what the pass conditions are. Not using the code. You should decide this is objectively what the right behavior is, and then verify it against the performance. I'm going to try and avoid using the actual prototype to work these out. And if I make a mistake, I make a mistake, and I'll have to fix it later. But yeah, so 3, 9. That's what I'm expecting. Then, after we've added 2 more players, presenting, so 2, 3, 9 is what we've moved to. We're adding more players, so that should be at 10 and 11. And then after the move, this should all move to the right one. So 3, 4, 10, 11, 12. Okay, so we've written a test case. Let's quickly run the tests and see what's happening. I'm expecting it to fail. That's quite important. Yes, failing. And the reason it's failing is one or more child tests has an error. Our case has an error, and arguments provided for method, but no parameters. Ah. I've not written something properly. Okay. I've missed something somewhere. Here we go. To pass the test case in. And this needs to be a test case. Okay. Passing our test case in. This might actually pass now. Yes. This test is passing because there's no errors in the compilation, but we're also not exerting anything. So the first thing we've got to do is make some assertions. So we're going to put test case dot total lights in here so that it makes the game of the right size. We're adding our players, and then we're going to do some assertions. And the way we've done assertions in the past is like this. So for each light check in test case starting positions dot light checks, I think that's right. Assert equal light controller. I need to get the light controller. Okay, is light on, light check position. Cool. And again, actually, I expect this test to still pass, because this is part of the game that already is working. Yeah, so it's still passing. Then we're going to move, and we're going to check that the I should rename this. This isn't actually that good of a name. After join. Let's just call it positions after join. Yep. The positions after join. These should still be correct because actually, is that right? No, I want positions after move. That's what I want. It's very important to name things well so that you can actually make sure you know what you're doing. Positions after move. Bastis, you asked, they're not supposed to move closer to the center after the new players join to make room for the movement, the thing you had in the last stream. So it depends on the size of the playing field. They only move closer to the center if they run out of space otherwise. I can show that off now. For a 15-player playing field, right now, I need 3 spaces to win, and I've got 1, 2, 3 spaces to the back. So 2 players can still start at the ideal position. If I add a player to the left, now they move to the center, because now we're running out of space. But the first join, they're not running out of space. I don't know, Bastis. So the thing is, so I'm writing my first test case where I'm using a playing field of size 15, and I'm hoping that's not something I have to worry about for 15. I will find out when I start running this, because right now what I'm doing is if I added, let's just refresh this. So I will end up at some point with 5 players. Let's just have a think. That's the initial position. Then we move. Then we add players to the right. So there'll be a total of 5 players at the end. And for a 3, that means there's a 3-person team here. So from a starting position, this does move us in 1. But I think we don't need to take into account starting positions in the same way when joining mid-game. Because when you join mid-game... Ooh, this is a tricky one. I've not come across this yet. So the initial point of this test is to make sure that when people join, they end up in the right place. I will add enough test cases to this so that we end up checking ideal positions and team sizes. But I hope this won't... I probably should just change it. I should change the initial test case to like 20, where it definitely doesn't matter. Because I'm not going to write... That's the other thing about this kind of process. I'm doing one feature at a time. So I'm not planning to write the code for this feature in the first instance to work for all future versions of the game. I just want this to work for the specific bug where you cannot join the team mid-play. It will definitely not work for other things like player sizing and maximum team sizing and everything like that, but a future test will cover that. That's not the point of the current test I'm writing. And so I don't really care about the code being perfect. And that's kind of quite the liberating way of doing this. I'm not thinking about the end game at this point. I'm thinking about only the next step to bring my game forward. And that means I don't have to even consider abstraction and reshuffling and all of those things yet, which is really freeing. So I think, just to quickly answer your question about people joining and moving, when a new game is being placed and we're resetting the ideal starting position based on the number of players, that's just kind of... That's the start of the game. Once the game starts and people start moving, I'm not going to reposition people. If you're only one pull away from winning, nothing that happens in the game should stop that being the case, that you're one pull away from winning. So I think rather than having to reshuffle people if more people join, I'll just make it so that I will limit the number of people who can join to prevent reshuffling being necessary. I think that's probably how I'll deal with that. People can join, but only as many as can fit the game. So let's say for 15... Oh, I'm not even going to think about that now, but I think that's the way I'll go with it. And it probably won't be a big problem for me specifically because my LED strips have 30 LEDs per meter. So I'm going to be working on a 30 LED playing field. So I think I can have easily 8 or 9 people in the game without having to even reshuffle away from the ideal starting position. But again, like I don't expect 20 people to be playing this, and I'll figure something else out if that does happen. I might like change the colors based on having like a higher player density or something, like where like a yellow light is 1 player or a blue light is 3 players or something like that. There's other ways of dealing with this where you can kind of figure that out visually, but let's just work on this first. So where were we up to? We were running the tests, still passing because nothing's broken yet, but things are about to break, which is nice. So, adding more players. Now our light check is going to be positions after join, and we should hit red. There we go, nice. Okay, so we are breaking. And the reason for that is people are in the wrong positions. So now I get to actually look at some code. Now we're going to look at our player join positions and our player. So, okay, so add player to the left team. Basically what I'm doing is get the number of players on the team, check that we're not already at the max. So if we can add more players in, we add a player and we set up the board. So I think this is fine. Does this need changing at all? We've got a max player per team. Add a player, move on, set up board. Now the question is, I think this is correct. We're just adding a player to the game. Set up board currently is responsible for setting the starting positions. And so with that in mind, what we probably should do is we should track whether the game has started. If it hasn't started, we do the starting positions. If it has started, we need to do something slightly different. Let's take that approach. So, if game is game started, I don't like that. Has game started. Let's make that private, probably. The game has not started. Set starting positions. Else. Set game positions. I'm going to create our field. Private boolean has game started. Set game positions is going to, at the moment, call the starting positions because I've not worked out what we're going to put in there yet. And we need to set the game has started. The game has started is going to start on false, but I think move will set that to true. And it needs to do it when an actual move happens. So I'll do it at the end. There, that's the logic. Now we just have to decide what do we do differently. So starting positions, we don't really track anything at the moment. We don't have a board history, we don't have a movement history, we just set up the ideal starting positions whenever we are told to. So either we need to do a whole lot of tracking in terms of who's moved where and why. Question, what's the point of bool if the same set and if and else? I will have different stuff, so that's the thing. So this will be two different things. So this is not going to be doing setting the starting positions. It's just a placeholder. So this will do something different. Don't worry, there will be different movements. I've just not quite decided yet how that's going to work. So the two options basically are we do a whole lot of tracking and we figure out where all the pieces have moved and where they should be, and then we add more players in that way. Or we just replay the starting positions with updated team sizes. I think replaying positions is easier, because all we've got to track is how close the teams are from winning. Because that's the vital schematic. It's basically how close is a team from winning at any one point. That's all we care about in terms of progress in this game. So do we track two variables, one for each team, or do we track one variable for the absolute positioning? I think, even though it's a bit silly, I'm going to track one for each team. So far I'm tracking everything team agnostic. So let's just do that. And let's call it player moves to win left and player moves to win right. Now we need to set those in the starting positions. Because we calculated in the starting positions, because it can be different for the team sizes. So here we go, steps to win. For starting positions, both teams have the same steps to win. So let's just do some tracking here. So team player moves to win left and player moves to win right. There, we're setting them at the starting point. Then move has to update these, because when we move, it changes. So, what's our condition if the winner team is left? Let's do it here. Player moves to win left. Correct. Thank you, computer. And player moves to... It's terrifying when the computer knows what I'm doing before I do. And here we just swap those around. The right team is winning, the left team is losing. There. So that in theory should handle all the tracking. Now we've got to convert this into some player placement. Where do we have that method? Move you down a bit. Set game positions. Okay, so what we do in starting positions is we work out our steps to win, and then for every player on the left, we get the winning spaces and start placing players offsetting by I. Let's do a similar thing with this, except we're offsetting by the places left for winning. And in fact, once we've done this, we can probably abstract this out, because both of these will be doing the exact same thing, just using different variables. So let's have a think. So for the left team, we need to find where are they starting from. So our steps to win comes from the center. So the winning spaces, we still need winning space. And we're going to do our player moves to win left, and our player moves to win right. It might be as easy as that. I have no idea. We'll have to find out. And this is the thing now, because we're doing test-driven development, we've written some code. I am not going to run the game. I'm not going to do visual testing on this. I'm going to run my tests and see what the tests say. Because that will tell me whether my code is correct or wrong. Okay, and it's breaking. And the reason it's breaking is line 406. True is false. Okay, we are in the light check. Ah, this is worrying. I've broken something that was working previously. So there's definitely something wrong in my code. So previously this was passing. So let's stick a breakpoint in and see what's going on. Okay, so we are doing a couple of assertions here. I don't know which one is wrong, so let's step through them. I should probably update the test slightly so that it tells me more accurate information over which one is wrong. But anyway, so we're doing a light check position. So position 3 should be on. So then if we do is light on here, I want to know which one we're checking for. Light is on, false. Position 3 should be on, and it's coming back as not on. Why is that? So what have we done to get to this point? We've added player team left, added player team left, added player team right. Is my if statement wrong? Oh, I don't want this one. Tug of War. Setup board. If not, game has started. Set starting positions. I'm expecting this to be hit, because we should be setting the starting position still. And I run this. Okay, so set starting positions. That's what we're doing. Good. Where are we coming from? New game. Don't care about this one. Add player left. Setting the starting positions. Add player left. Add player right. Let's step through this one now. So the number of left team. So turn light on. Pop down here. So winning space is 7. Minus steps to win 2. Interesting. Why is it steps to win 2? Maybe that's fine. Minus 0. So we're turning on number 5. Okay. Yeah, so we're turning on number 5. And we're turning on. Oh, didn't work it out that time. But 4, essentially. 5, 4, and 9. Whereas what we should be turning on... Oh? Where are we? Look at test case. Starting positions. Three, 4, 10. 2, 3, 9. Okay, I'm lost. Don't know why it's doing that. Let's run the game. I've definitely broken something badly. Look at this. I've got lights on already. Shouldn't be any lights on. Right, I might be misunderstanding how something works. This bit here. This is what I'm doing wrong. Might still be wrong, but let's have a go with that. Nope. What if I get rid of this entirely? Because essentially my starting positions are broken. I don't think I've changed anything with those. Unless I have. Okay, no, there it is. Oh. That's why. This is player count right, not player left. Yeah, that'll do it. It's not my misunderstanding of C#, it's my misability to write clean code. 423, different fail. That's better. Okay, so far that's all correct. Now doing move, correct. Add player right. Inverted. You're right, Bastis. It is always something tiny annoying. I spent on my last stream, I spent a good 10 minutes looking for a bug. And it turned out I just had done some maths and I hadn't put brackets in. And there's an addition and a division. And it was doing them in the wrong order. So I added some brackets and everything worked. It's always the tiny little details like that. Okay, so I think I have something wrong in the logic for player placement. So let's have a look at that. So in-game positions. Johnny! Hey, mate. Thanks for the follow. Good to see you, bud. How you doing? Okay, so we're doing number of players left. This should be correct. Maybe I'm setting this wrong somewhere. So if the winner is the left team, player moves to win left minus and player moves to win right plus. So that is correct. I think. Ah, no, I've got the entire logic back to front. It's not player moves to win, it's player moves to lose. The closer you are to the middle, the closer you are to losing. That's silly. Oh, no, that's confusing again. Well, let's do this for now. But I think that's confusing, and that's going to confuse me. So, because when we're doing our player win, so if the left team is winning, that's fine. So I understand the left team is the winner. Therefore, player moves to lose left goes up. So they're further away from losing. That's fine. But here, set game positions. Let's say we're looping over the left team. We are getting our winning spaces, and then player moves to lose right. Is it? Or can I just leave that? No, that's fine. Okay, cool. I think that's usable. Right, let's have a look. Test passes. Whoop, 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 whoop. Wrap in a small method to name the logic and intend. Maybe, Johnny. I don't want to do too many different methods. There's a fine balance between granularity of too granular and not granular enough. I know what you mean with that, though. Not a terrible idea. Right. Last test assertion, and then I think we'll call it a day, guys. I know you just got here, Johnny, but I'm doing a short stream tonight because I've got family stuff to attend to. So, what have we done? Oh, just for your information, Johnny, I'm doing in-game player join logic. So basically, I've got a Tug of War style game where, come on. But basically, you add a bunch of players in, and when you move, you pull the opposing team closer to death, essentially. But what I wanted to do is I'm wanting to be able to add players in game so that they join another team and then can change the outcome. So rather than the traditional Tug of War where you have, the same number of people on either side, I want to do it like almost like a kind of popularity contest Tug of War. So it's like, you can just jump in whenever and start pulling. I might even add like team switching if you want to be a traitor and abandon your team. But we'll see. Okay, so we're at the point where we're checking our final positions after we've joined and moved. So that is position after join and move, and let's rename this to something more usable. Positions after join and move. That'll do. And if this passes, I will eat my hat. Luckily, I'm not wearing a hat. Whoa. It works. Nice. Movement. Nice. Cool, so the next bug we need to fix is teams are too big for the game. Cool. That'll be next week's job. Yes, that's the point, Johnny. So basically what I'm doing is I've got these LED strips. At some point I'll get rid of the green screen. I've got like a shelf behind me, so these LED strips are just gonna they're gonna exist on the shelf, and basically Twitch chat is going to be able to start Tug of War games and play them in the background without me even having to do anything. It'll just exist as part of the stream. So I've been working on something completely different, and you can just, you know, tug each other off, and all that side of stuff. Cool. I'll call it there. I'm already 10 minutes over my planned time. But yeah, Bastis, Johnny, nice of you to join me. IBO Xa, thanks for joining and asking some questions. It's been fun. See you later, Johnny. Yeah, I'll get back into my regular streaming routine in the new year. So usually on Tuesdays or Thursdays at around about this time. But yeah, hope to see you around. See you on one of Zach's streams if I make it. Cool, guys. Take care. Bye-bye.